As the sun dips below the horizon, the city of Sparkle Light begins to hum. Warm yellow lights flicker on in the windows, casting a peaceful, buzzing glow across the streets. Keeping those lights steady is the immense responsibility of Queen Electra. She oversees the grid. It's instantaneous. But that split-second illumination is actually the final step of a massive, silent journey across an invisible network. The Queen cannot generate and route all that energy by herself. Maintaining a continuous flow of power requires a perfectly synchronized system of heavy machinery and natural forces working together hundreds of miles away. Tracing that unseen supply chain reveals exactly how much coordinated engineering it takes to do something as simple as illuminating a dark room. To find the source of that bedroom light, we have to travel out to the distant wilderness, where tall, majestic hills meet rushing rivers. This is where the heavy lifting happens. Enormous generators, the power giants of the grid, capture the raw kinetic energy of blowing wind, of flowing water, and radiating sunshine. By spinning massive turbines or absorbing solar rays, these giants convert environmental movement into concentrated, glowing sparks of raw electrical current. Every quiet, cozy reading lamp in the city is actually running on immense natural forces that have been extracted directly from the earth. Generating the current is only the first step. To move those freshly forged sparks out of the wilderness, the grid relies on thick, highly conductive cables known as transmission lines. This maps out those high-voltage highways. Long, unbroken silver lines radiate from generation sites, cutting across rough mountains to population centers. Because electricity cannot easily be stored, it is pushed out immediately. The current travels at light speed, carrying enormous loads of high-voltage power across these lines. Without these long-distance conductive pathways, all the kinetic energy captured by distant turbines would be permanently stranded in the mountains, completely useless to the city. Once that high-speed current reaches the outskirts of the residential neighborhoods, it faces a structural problem. It is moving much too fast and carrying far too much voltage for a household outlet to handle safely. Before the electricity can cross into a home, it has to be intercepted by heavy metal boxes stationed on utility poles and street corners, devices called transformers. Here is how a step-down transformer operates. A large high-voltage energy pulse enters the primary coil, and the transformer actively reduces the pressure, stepping it down into softer sparks. Conversely, if pressure drops, a transformer boosts the voltage, guaranteeing a steady flow for delicate devices. These mechanical helpers act as a critical safety buffer. They translate the violent, raw power of nature into a controlled current that humans can safely bring into their living rooms. Stepped down and stabilized, the electrical current finally crosses the threshold, traveling through the insulated wiring hidden inside the walls of Sparkle Light's houses. At the end of the line, it reaches the outlet. It flows into the ceiling fans to keep the room cool, powers up the tiny motors inside singing toys, and pushes through the filament of a little bedside lamp named Globy. In the moment the room lights up, those devices are cashing in on the heavy labor of the river turbines and the high-voltage transmission lines hundreds of miles away. The quiet, steady glow of a bedroom lamp is the successful endpoint of an incredibly complex, continent-spanning electrical supply chain. But because the supply chain is constantly running, the system relies on the people at the end of the line. If a child falls asleep with the ceiling lights ablaze and the toys left running, they place unnecessary strain on the grid. Queen Electra's central rule for the entire city is that electrical power is a finite resource that requires active conservation. Every watt of electricity requires wind turning a blade or water pushing a turbine. Drawing power for an empty room forces generators to work harder and wastes the natural energy it took to get it there. When you flick the switch off right before getting into bed, you immediately reduce the load on the power grid, allowing the entire system to settle into a low, sustainable hum for the night. Managing our own consumption respects the immense physical effort required to generate that current. Conserving what we use ensures the grid remains a reliable, steady companion for the future.